Ever pondered how the colossal complexity of data can be simplified and understood? In our world, we are ceaselessly bombarded with data, a vast ocean of numbers, facts, and figures that can quickly become overwhelming. This is where the concept of data complexity enters the stage. It's the intricate web of connections, patterns, and structures hidden within this sea of information. This complexity poses a significant challenge. How can we interpret and understand this data effectively? This is where unsupervised learning, a subset of machine learning, comes into play. It's like a seasoned explorer, fearlessly venturing into the uncharted wilderness of data, searching for hidden patterns and structures. Unsupervised learning doesn't need pre-existing labels or classifications. It's self-sufficient, capable of finding its own way through the data jungle. And within this realm of unsupervised learning, two powerful tools stand out: clustering and dimensionality reduction. Unsupervised learning, particularly clustering and dimensionality reduction, can be our torchbearers in this labyrinth of data complexity. Imagine you are in a room full of objects. How would you organize them? Most likely you'd naturally group similar objects together. This, in essence, is clustering. In the vast universe of data, clustering is like our own personal North Star, guiding us through the complexities, illuminating the path to understanding. It's a process that takes a whirlwind of data points and groups them together based on shared characteristics or features. Just like how you'd group apples with apples and oranges with oranges, clustering groups similar data points together. But how exactly does it work? It's all about proximity. Imagine a flock of birds flying together. Why do they do that? Because they have a shared destination. Similarly, data points that share common features or characteristics tend to be closer to one another in the data space. Clustering algorithms exploit this proximity to form groups or clusters. But why is clustering so crucial? It's because it simplifies our complex data by revealing hidden patterns and structures. Think about it. If you have a room full of random objects, it would be much easier to understand and navigate if they were organized into groups. Clustering does precisely that, but for data. It organizes the chaos, making it easier for us to understand, analyze, and derive insights from the data. Clustering, thus, serves as a cardinal tool to uncover hidden patterns and structures within our data. Now, imagine each object in the room has multiple characteristics: color, size, shape, and so on. This is where dimensionality reduction comes into play. Picture a bustling city with countless skyscrapers, each representing a variable or feature in your dataset. The more buildings there are, the more complex the cityscape. But what if we could simplify this bustling metropolis into a quaint town without losing the essence of what makes it unique? That, in essence, is the magic of dimensionality reduction. Dimensionality reduction is like the skilled architect who, with a keen eye for detail, intelligently selects the most defining characteristics of the city. The architect does not just randomly bulldoze buildings but chooses to keep those that contribute significantly to the city's identity. Similarly, dimensionality reduction techniques help us to sift through the multitude of features in our dataset, keeping only those that hold the most information. This process has two significant benefits. First, it helps us visualize our data better. By reducing the number of dimensions, we can plot our data on a 2- or 3-dimensional graph, making it easier to spot patterns and correlations. Second, it significantly reduces computational costs. With fewer variables to process, our algorithms work faster and more efficiently, saving us both time and computational resources. Dimensionality reduction, therefore, not just simplifies our data, but also accelerates our journey towards meaningful insights. We've traversed the realms of unsupervised learning, from clustering to dimensionality reduction. We started our journey by understanding the enigma of data complexity. Our world is teeming with data, diverse and intricate. Unsupervised learning, a remarkable concept, steps in to address this complexity, transforming it from a challenge into an opportunity. Next, we explored the concept of clustering, a technique that groups similar data points together, creating a map of patterns and structures that would otherwise remain hidden in the vast expanse of information. Clustering, thus, holds the power to reveal the hidden narratives within data. We then delved into the art of dimensionality reduction, a process that simplifies data without losing critical information. It's like capturing the essence of a novel in its summary, making it more accessible and manageable. With these tools at our disposal, the complexity of data no longer remains an enigma, but transforms into a treasure trove of insights waiting to be discovered.